Okay, welcome. Today we're going to have a talk about how to create a test case within Pump. For this demonstration, we're going to be creating a test case for the standard Genesis demo serve environment. And for those who aren't familiar, that is a demo environment released by Genesis. We'll dial the normal in-dial number of 8011, and that will present us with the opportunity to enter in a username and password, followed by a main menu, and then in that main menu we'll select number 3 for a new case. So when we dial that, it sounds something like the following.
Please enter your account number.
So I've dialed 8011, now we'll enter the account number of 1234.
And your PIN.
And again we'll enter 1234 for our gold level account.
Welcome. For billing questions, press 1. For new accounts, press 2. For changes and additions to an existing account, press 3.
Okay, so we want to enter 3 now because we're changing an existing account.
Please hold while I transfer your call to the next available agent. All of our agents are currently busy, but we'll be with you as soon as possible.
Okay, so I've hung up on that now. So after we enter 3, it puts us into a queue looking for that agent. So once we understand what it is we're testing, then we can go about creating our test case. So you'll see we're logged into Pump here. We're on the main status page. To create a new test case, we go into the test cases folder. And we can create a test case from here. Let us create a new test case within the examples folder. So we'll select that folder and we'll press plus to create a new test case. Let's create a new test case 51. So we will open that test case and we can give the test case a name straight away. So let us call this demo test case 8011 changes. And we'll spell it correctly. Okay, then test cases, that's saved. We can go in, and this has actually come up with a few sample steps, as it does whenever we create a new test case. So it's actually come up, and the sample steps actually already dial the correct number. So the first thing we do when we make a call, when we want to create a new call, is we need to select what number we want to dial. Now this can either be an internal or a fully qualified number against our configured SIP switch. So in this case we're dialing 8011. The first thing that we expect should have happened is the next step, is we expect the call should be answered. Now whenever we talk about times to answer and times for responses within Pump, we have a couple of windows. We've got the window here saying we really would prefer the call to be answered within 1 second. So if the call's answered within 1 second or 1,000 milliseconds, then the call would be considered successful for this first test step. However, ideally it should be answered within a second. We're actually happy for it to be answered in less than 2 seconds. So anywhere from 1 second to 2 seconds, we won't fail the call, but we'll mark it as an acceptable call and continue. Anything longer than 2 seconds would immediately fail the call. So we've got 1 second and 2 seconds. Then the next step we want to do is, after it's been answered, you remember it says please enter your account number. While we're waiting for that audio, we need to give the IVR time to say that, and that is around 2 to 3 seconds. So let's change this to a 3-second delay while we're waiting for that prompt to enter. Then it'll ask us to enter our account number. Now we know that there is a gold account number, because we know our system that we're testing, with a user ID of 1234. So we'll enter 1234 there in the digits. Now we could just as easily also enter a step here where we can play a wave file if we were a speech-driven IVR, just as simply. So we could drive an IVR by saying, but this is a DTMF IVR. So we'll enter 1, 2, 3, 4. Then we'll wait Now you remember within our test call flow, after we entered 1, 2, 3, 4, it said, and enter your password. So again, we need to give it a delay while it enters that. And then we want to add in another DTMF block. Let's just delete this release call for now. And we will make that also 1, 2, 3, 4. Following that, there was a main menu. So there should be a delay while it plays that menu. Of around 5 seconds. And then we wanted to press 3 for changed options. Often when you're creating a test case, you'll actually dial the call manually with a notepad in your hand and write down the rough timings and the DTMF presses you do, just so there's less playing around. Following this, we'll let the call queue for around 20 seconds, and then we'll drop the audio. So let's put in 20-second delay. And then we'll, from call control, we'll release the call. Okay, at this point, we've got the bare bones of a test case written. We're dialing 8011, we're expecting the call to be answered, then waiting for 3 seconds, punching in 1, 2, 3, 4, waiting for 3 seconds, punching in our password, waiting for around 5 seconds, entering 3 for changes, and then we're waiting 20 seconds and hanging up on the call. This is the call from the GUI perspective. We could actually look at the same call from a text-based Gherkin perspective. These test cases, any test case will be viewed as a Gherkin or as a test step. Behind the scenes, they're all stored as Gherkins. Gherkins tend to be quite easy to work with once people are used to the system, and they're also human readable and text-based, so you can copy them and paste them and print them out and do all these good things. But anything you do in one format, you can do in the other. And so for this demo, we went in with the GUI based. That's fine, we can jump back and forth at will. Okay, so we've created the bare bones of a test case. Now what we should do is execute that just to make sure that we have no problems up until now, and then we'll go in and we'll create some assertions. So in order to execute a test case, what we need to do is we need to create a test set. So I've created a new test set, and we'll add that test case. It was under examples to that test case, and we can execute that once now. So executing once, as we expect, will run the call flow one time and allow us to verify it's running. Now, just by chance, as we've gone back here, our new test case is running here up the top. However, there was an existing scheduled test case which was running, which is just finished as I went to talk about it. Okay, so the call flow should be around 30 seconds long, based on the steps we had. So that should almost be done now. Okay, I can see it's just hung up. Okay, so that call has completed now. So now we can drill down and have a look at the result. Okay, we click on that, and we can see the call is there. I can play that call now. When I do this, there'll be a momentary hiccup in the audio.
Please enter your account number. And your PIN? Welcome. For billing questions, press 1. For new accounts, press 2. Please hold while I transfer your call to the next available agent. All of our agents are currently busy, but we'll be with you as soon as possible.
Okay, so we can see that call appears successful. It's been placed, it's dialed the DTMF, we can see the system under test has responded, and we heard the correct audio. In terms of jumping back to the test case itself, when we look at that test case, there is only one assertion here. And most of the steps we have are call flow steps. So we dialed a number, we waited a while, we entered DTMF, we may do some speech entry, we could potentially stop and wait for silence or audio or a few other steps, and we can go through those in further videos. And then we hang up. Once we get to this part of the call, now we can start to apply what a tester would normally refer to as assertions about the call. So, what would these assertions look like? We've got one, which is, well, we expected the call should have gone for about 33 seconds. So the call shouldn't have gone for less than 27 seconds. It certainly shouldn't have gone for more than 40 seconds. So we could put in an assertion immediately about the expected call length. So let's go to call properties and look at call length. Okay, so we expect the call should be less than 40 seconds. However, we also, and we might warn if it gets above about 38 seconds. It should actually be 33 seconds. But however, if it's less than 30 seconds, now we know it shouldn't be possible for it to go for less than 30 seconds, because if we look at our steps, we've got a 20 second, 25 second, 28 second, 31 seconds. So it should be not possible for the call to go for less than 31 seconds. So we know if it hung up before 30 seconds in, there's been a problem. So we can create this test step straight away based on the RTP, based on the call length. What other things could we look at? Well, we could ensure that not only was the call answered within a certain period, but that RTP was established within a certain period of time. So after the call is answered, we also expect that the system under test will start streaming some sort of RTP at us. Again, we've got these Goldilocks periods of it. It should happen within, in this case, 300 milliseconds. Warning from 200 milliseconds to 300 milliseconds, but after 300 milliseconds, it's a straight error. So let's change these to 1,000 and 800 just for demonstration purposes. We've got some best practices guides around what appropriate values for these settings, which we can talk through another time. We also can look at what was the RTP jitter like within this call. And that's one of the key things you can get using Pump versus other testing environments, is because we actually on the network, providing the calls, keeping complete network traces of every packet that flew back and forth, we can actually investigate what the RTP jitter and dropped packets and whatnot look like, and warn as we're starting to see issues. The problem with RTP jitter when you're testing externally is a lot of RTP jitter is hidden by the jitter buffer. And as things start to get close to actually going bad, you have no idea. The audio still sounds fine, right up until when you suddenly hit a wall and you start getting packets dropped all over the place because your jitter's too high, and it's too late. While if you're able to monitor the jitter like we do, we can actually warn as you're starting to approach a jitter buffer problem, and find that out within load testing well ahead of actual production issues. So in this case, we're looking for maximum jitter of 70 and 50. They're pretty good values based on the normal jitter buffers applied by software, by hardware. And then we also can track the mean jitter. We've looked at call length. Okay, so these are some fairly basic, straightforward assertions we can apply. So let's go back to our previous call where we had it. And again, you'll see that there's only the one assertion we placed. What if we wanted, we can actually go back and reapply these new assertions to the existing test run. I know that doesn't sound much because we were just in an individual test run which only had one call, but imagine you had an example where it had a test case with 100 calls or 40,000 calls. Being able to reapply assertions on existing calls, because we've got all of the data there, is both a great time and cost saving and really improves your agility. So let's go ahead and reprocess that call and refresh it. Again, we still see it pass, well, we expect it to pass. Now this time when we drill down, we see a whole lot of reasons why it passed. Not only the answer time, but yes, it had the correct length. The RTP was established within a valid time, and the max jitter and mean jitter both look fine. Again, these are pretty straightforward. Then we can start to drill a little bit further down. On this screen, under the download button, you've got a few options. One you'd really expect, which is being able to download the call recording. We can also download the complete network trace of what went on. Engineers love this. We pull down a PCAP, and this is a network trace of everything that happened within that call, and we can open it up at a Wireshark and have a look. We can also download a call export. And a call export's great for support personnel. We can pull down a zip file with the call recording, all of the details on the screen that we've got, the logs from the pump side of things, the network trace, zip it all up, and it's ready to email in the case of a support issue. But what I wanted to drill down for a moment is our processing log. And our processing log shows what pump's doing in the background. But one of the things it does straight up near the top is it dumps all of the attached data that it's managed to gather from the system under test. So in this case, from Genesis. And we can include this data in assertions about the call. So we can look at the attached data. So here we can see that there should be a customer segment of gold. Well, we expect that because we entered a gold username and password. So we can actually verify on the test case that this customer segment was equal to gold. So how do we do that within the test case? Let's go and open up the test case itself again. And go in here. And go to Gherkins in routing and call data and add a new step saying data present. Customer segment was actually the default, and the value we're looking for was gold. So all of these steps as we add them, they come up with a sensible suggestions as to what some values are, some sample values, to make it obvious the way the step should be used. So in that case, we were checking that the customer segment was gold. If we remember, there was also a second key which was which could be relevant, and that is, let's pull up that trace again, that the service we selected was changes. So let's go in here and just for fun, to show we can copy and paste them, the customer segment one. So changes, and the value was service. Of course, there's also IntelliSense on this, so you can start to type, spelling then correctly. And, sorry, strange keyboard. And it gives you all of the different options it could select. These are all regex driven, so you can create quite complex flows, but pretty simple. We may also want to verify some attached data does not exist. So in that case, then matched does not contain user data. Okay, so customer segment. Silver. And you saw when I had a typo within the test case, there was an issue with it, that we get a warning there telling us that the syntax of the line's wrong. Okay, so you generally use customer call does not match attached data, looking for error codes or verifying that you didn't go down the wrong path of an IVR. Okay, so then we can do one final thing, which is also extremely important. which is we could add assertions around what text we actually heard when we called the IVR. So as you may recall, when we called the IVR, it played a message along the lines of,
Please enter your account number.
please enter your account number. And that is this initial bit of audio here. So how do we go about testing for that? Well, what we do is we firstly need to load the audio that we're looking for into our audio library. So one of the really simple way of doing that is we can extract it straight from this call in front of us. What we do is we go into the call, we select the section of text, the section of audio we want to look for, and then that's there. We can say, then we give that a name. Please enter. And hit save. Okay, so what's that done? If we jump back into the main pump screen, under our prompt library, and we sort by the latest ID, we'll see this prompt here, which has please enter. But our headphones are plugged in, so we can't hear that.
Please enter your account number.
Okay, if we're good people, then we'd write that in the transcription. Okay, and if we look in references, we see that's not referenced anywhere. We expect that. Okay, so let's grab that prompt and throw it into the DemoServe library. And we've got please enter, prompt 62. Okay, so how do we go about using this and verifying it? Let's go back into our test case. And we can add an extra assertion, then let's just add it as a audio prompt played. Jump back into our Gherkin and have a look at that. Okay, so, and I've played, we need to enter the DemoServe / please enter. And prompt played, please enter, was played within a time, which in this case is 0 seconds, and an accuracy of 0. Look at when the audio was played. Now this is played from the start of call, so we expect it to occur quite quickly. So in this case, let's say if this has not started within 1 second of the start of the call, then we should fail the call. Of course, we've got our Goldilocks period of we really want it within 1 second. However, if it occurs after 800 milliseconds, we'll issue a warning about the call. However, with any audio, there's a time when it's too late to hear it, so we should have heard it in response to a DTMF press or the call starting. There's also a time where it's too early to hear it. Now this shouldn't occur before the start of call, so 0 milliseconds is the time. If we were looking at audio that occurred in response to a prompt, then we would normally we'd set this to the same number of seconds into the call that the DTMF prompt was entered. So on the one hand, we need to look that the call was, that the audio arrived at the right time. The other thing we need to verify is that the audio was of the appropriate quality or accuracy. So you hear that we heard the audio at the right time, but we need to make sure that we heard the right thing. And for that, we look at our accuracy, our percentage match when we say, this is what we heard, this is what we expected to hear. Was it a 100% match? Was it a 98% match? Was it a 90% match? And we've got our tolerance, how much we're willing to accept degradation of this audio signal for during our test case. Now this is a little bit system dependent, what you'd want to set this to. But given we're on net dialing a DTMF prompt, we expect this to be a 100% match. And we do some pretty tricky maths behind the scenes to compare the two audios and work out what we view as our an appropriate match and how different they are. So let us set a failure. If it's anything less than a 98% match, then we'll fail the call. If it goes below 99%, then we'll issue a warning. Now let us, while we're doing this, extract a second bit of audio, which is this, the part where it says,
Welcome. For billing questions, press 1.
okay, welcome for billing questions, press 1. And that is this section here. So let's extract that out and call it welcome message. Save. Now this prompt we know is going to occur roughly 8 seconds into the call, which we can see here from this screen. So let's jump back into our prompt library. Got to please enter. If we were good people, we'd enter a transcription, but we won't in this case. And our welcome message. We will add this welcome message back to the demo serve. So we've got demo serve / welcome message. Then we'll jump back into our test case. And we'll verify that. So what would happen if we entered the wrong text? It would come up and say there's an error, that message prompt isn't found, but that's how I spelled it, MSG. Okay. And we need to specify when we expect the prompt should have been heard. So we know that it can't have been heard in less than 6 seconds. So that's 3 seconds before we heard the enter username, 3 seconds before we enter the password, and then it comes back. So if we heard it before 6 seconds, then it's definitely a failure. Now we actually expect around, we've got the DTMF tones being sent, that'll take about 800 milliseconds to send, so it's actually more like 7 seconds into the call before we hear the audio. So let's warn if we don't hear anything within, say, 8.5 seconds. And if we don't hear the audio before 9 seconds, we'll outright fail the call. Okay, so now we've done those updates. Let us go in and re-execute that test set from scratch. We could, of course, with the lovely birds at the back, reprocess the other one, but it's one call. Let's run it again from scratch. So now the call is placing. And the call should take about 35 seconds. Same call flow as before. Okay, so now the call is complete and it's passed. Let's open it up. And we can see basically all of our test steps have passed and we've been successful. So that's how we go about creating a test case in Pump. Thank you very much for your time today.